Hello everybody and welcome to another Blender tutorial. It will be similar to the previous one. I will try to recreate the image I did for my desktop. And it's actually a product of another tutorial that is on the YouTube on the channel GreyscaleGorilla. Sorry for the pronunciation. They are making awesome tutorials, but they are making tutorials for Cinema 4D. And I will try to recreate the same tutorial but for the Blender, so using just the tools provided in the Blender, with using of course the similar methods or probably exactly the same methods. So just jump into the Blender, and first thing first, if you want to follow this tutorial you will actually need add-on to Blender that is named animation nodes. The link is of course in the description. You can download it, install as any other add-on to Blender, and if you want actually the same exact settings and layout of my Blender, because I just can't anymore go back to the default settings and try to make the tutorial there, so I put my config file to the Dropbox or Google Disk folder, I believe, and put the link in the description. You can download it. It's a file named after the version, so this file will be named 2.78. and if you are on Windows you will just go to this location, see users, your username, app data. Be careful, this is a hidden folder, roaming, Blender Foundation, Blender, and there should already be this folder named 2.78 if you installed the Blender the traditional way. You just replace this folder and you will have activated the same add-ons, installed the same add-ons, same theme, same window layout, same shortcut settings as I do, so you can follow this tutorial more one-to-one. But the method I will use is same for any settings of Blender. You will just have little different visual cues, as you can say. Well, don't get distracted disrupted, sorry for my English, anymore, and let's go straight to the tutorial. For the image on my desktop, I've used the mesh provided in the Cinema 4D, and unfortunately I'm not able, or I shouldn't share it with you as the starting point, so I will just show the method on the monkey mesh, on the well-known Susan. It will probably not be that spectacular, but method is the same, and that's why we are learning it. Well, first of all we need deform this mesh a little bit. We will use just the modifiers. It should be same old story for now. So add modifier and displacement. Add new texture for some randomness, and best randomness for displacement is of course clouds, where they are here. Clouds, it looks actually not that bad. Play with the scale a little bit. Okay, it's not exact science, this is just eyeballing it as you want. You just want random geometry, but as you can see it's too much non-consistent. It doesn't have enough geometry to play with the texture, so we add the geometry not by subdividing the mesh directly, but adding a subdivision surface modifier. But we don't want the subdivision surface be active after the displacement but before, so we will use this little arrow to put it above the displacement, so the mesh is subdivided first and then displaced by the texture. Subdivision could be like 2 levels. it starts to look really weird. I get it. You can adjust the strength a little bit, set the mid level to 0, so it's kind of fluffy and not exactly, you are not getting rid of the intersecting faces, but you are kind of making them not that appear in the render. So get this as random as you can get. This looks kind of good. And because we added geometry just to displace it, we can remove it and get more random and the glass looking the mesh with another modifier, with the decimate modifier. The ratio, you can play with it as you want, which suits you. I like to get back to the original poly count, so the 2 subdivisions for the subsurf actually make 16 times more vertices, or if I count, yes, it should be 16 times more polygons to the mesh. So in this percentage or this ratio, I will just type 1 divided by 16 and I should get to the original poly count, but distorted and very random, jagged. You can see all these edges. Hit the triangulate, it will not have too much effect, but it will add all these edges that you can actually see between the polygons, and it's all for the object setup as it is. And now we would like to add these little spheres on each vertex and the wires on the edges. In Cinema 4D they have something called atom array that actually created for you, and there is a method by you converting this mesh to curve, adding bevel to that curve, and add duplicates of some spheres, and it's not that complicated to actually create it, the effect, but it's one use only. But if we are using the animation nodes, we will go here to the node setup. We can create some preset. It's maybe will be kind of complicated to understand at the first time, but it will be pretty universal and you can use it to any object that you want. So just let's start it and I will explain it as we go. If you install successfully the animation nodes, you have here the materials, textures, composition, and here is the new animation nodes tab. Click just new tree, and first of all here on the left side you can go to animation nodes, and here is how often it will be executed, and it's set to always, so it will try to execute anything that you create here as fast and as often as it can, and it can really slow the computer, so just uncheck the always and check just when the tree is changed somehow or some property is changed in the tree. It will be enough for our settings. And now first what we need the sphere that will be copied to all the vertices of this Susan object. We can just create the sphere, just ecosphere, nothing more to set up, and here in the animation nodes we need access to vertices of Susan. So just Shift A to add some node, and we will need access to mesh and mesh object mesh data. Here is node that takes as input one object and outputs the vertices, edges, polygon, anything that we need to work with, because we need the vertex locations for instances of the icosphere. So in the workspace, it's good. We need to use modifiers because the Susan is severely deformed by them. And here just pick the Susan. You can just pick from here, and if you have too many objects, just select the Susan and click on this icon, and Susan is selected. Now here we have all the vertices that we need. Also, we need instances or duplicates of this icosphere. It's managed by another node in the object instancer. Instancer takes again object that will be duplicated. So if we have selected the icosphere, just press this icon, icosphere is here, and number of instances should be equal to number of vertices of the monkey, of the Susan. Because we want this to be universal, we don't want to count the vertices just once. We want them count anytime this is executed. We have all the vertices here. We just count the length of the list. So list get length, and it will take all the vertices, and here is output is number of vertices in this mesh. So if I put this number to instances, in this scene is now as many icospheres as vertices on the Susan mesh, and all is here in this empty, so the scene is clear and manageable. Okay, now we need to place all the spheres on the vertex locations itself, and we need loop for it. Loop is something that happens over and over and over for each sphere or each duplicate of the sphere. So we add the node subprograms loop, and loops in animation nodes work kind of differently. You can think of them as groups in materials nodes. They are just separated, and from now on everything that will be connected to this node will have this darker bluish color, and it will be part of this loop, and it will be separated from everything else, and we will add it as another node. So we are creating something like a group. We can name it. This loop will be, for example, dupliverts, because that's what we are kind of recreating, the effect of dupliverts. So now if we want to add another node and subprograms, we have new subprogram named duplivert. So if I add it here, it have just one input, in iterations of number, how many times this loop will be invoked. Well, we want to iterate through all the spheres, so we need list of objects, so all these objects. So add new iterator, objects, object list. So here we add all the objects, all the spheres from this instancer, and we need all the vertex locations. So add again new iterator, and vertex locations are just vectors in 3D space, so we need vector list. It should be enough, it should be all. So just vertex locations add as list of all vectors. So let's recap. we have our Susan, we have all the vertices, the location of all vertices of its mesh. We get the length, how many of the vertices are, and we make here enough ecospheres for each vertex. We now put all the ecospheres and all the vertex locations to the loop, so you can look at this as for all the objects and for all the vectors, what should it do? It should go to object transform output. It will take object and change its location, rotation or scale accordingly as we set it. So we will take the object. You have to think of this as we will take every object that is posted here and we will change its location x, y and z, and the location will be this vector. So now you can see in the viewport already that all these spheres are now in the places or on the same locations as the vertices of the Susan, and we just want to somehow change the scale. You can change the scale of the mesh of the ecosphere itself, or you can change the scale here. Just activate X, Y and Z for the scale, and here create vector from value, where it is from value. It will just take one value and put it 3 times to the vector. So X, Y and Z will be the same. Plug it here and you can now change the size of the sphere. And this is how we create the dots. We can here hide the the first ecosphere and change this value something like 0.01, little small spheres, and you can see they are in all vertices. Okay, and now it will be good to have these edges. It will be actually or at least I think kind of easier. I will put this loop on the side, and we will do it with the curve. So just go to spline and create from edges, and it will take again the vertices of the Susan and the edges of the Susan, and this node created the spline, the NURBS curve that we will change the bevel and so on. So add the again spline object output. We don't have the object in the scene, we can just add it with this plus sign. Connect this spline with the geometry data of the target that is now added to the scene, and activate that we want to change it. And now there is curve that follows all edges in the mesh of the Susan or any other object that we will put here. Also, to be able to render it, we need to change the thickness, which is bevel depth, again some really small value. You can see that the effect is quite high, and you can also change the resolution of this curve. 3 is more than enough, I think. So now we can go back to the default view to see what we are modeled, and I think it's kind of there. And the advantage of this method over other methods that are available is it's adaptive. You can now do it for any other object, and also you can change the displacement, for example, here, and the changes are still live. anything that was created by the animation nodes is not updated, but you should actually know why. If you remember, when we go to the went to the animation nodes, we turned off the always button, so it's not executed as many times, or it's not executed constantly. So we can change anything in the tree. It would invoke the execution, or just click execute node 3 and it will be recalculated. Okay, now to some materials before we make the final render. There should be already camera in the scene, so just jump to the camera. Let's find some nice angle to render this. I will use here view lock camera to view and change the render, the composition like this. It's kind of cool. And for the materials, it will be really simple. Select the curve object. It should be kind of metallic. Metallic here means where are the nodes here. It's not diffuse, but shader glossy. Make it multiscatter GGX, which is for the metallic materials, and multiscatter is something that tries to keep the values of the reflected light more physically correct. But we are here aiming just for the visual appeal. Go to rendered view, and in this settings we actually can see pretty much anything because we just have white world. So first of all, change the world, and the thing I'm using pretty much all the time here, just Ctrl T if you have addon node wrangler activated, or just add the environment texture here. Open, find some environment texture. It actually can be anything, not even HDR or EXR. It can be JPEG, PNG, whatever, just to make a color variation in the light that's emitting on our scene. I will pick, for example, this. Why not? Let's open the image. Well, it's not that bad. I will just change in film the exposure a little bit, so it's lighter, the image. Now go back to the materials. The glossy is nice, but let's set the roughness to some really small value and make some variation in the normals of the material. And I will use a very generic method to just randomize them, and for this I will use texture noise, crank up the detail as high as it's possible, duplicate it and change the scale to something that is more than 10 times bigger. And now color mix, and mix those factor with 50% or 0.5 for each. And this is something that should be pretty random. So vector bump, put it to high, normals there. Let's just move it a little bit back. And this bump should be really subtle, not anything that is actually not noticeable. So 0.01 and 0.1 should be more than enough. let's name the material to metal and select the icosphere and put the material here. So all the icospheres are metals. The material will be redistributed to all of the icospheres in the scene because they all share the same mesh. And just now just make the material for the Susan itself, the material. If you downloaded the config, you should just be able to go to group, dielectric, connect this, change the color to something that you like, crank up the roughness, but really low. Reflectivity can be 1, why not? And it's pretty much all for this material. We will just use the same trick for the normals, so they are not that consistent. Just go to the metal, select everything we need, Ctrl C, material, Ctrl V, connect the normals, and everything looks pretty good. Another thing, just for the render, add an empty for the focusing and put it somewhere the camera should be focused, so we get some depth of field. Named it focus, for example. Select the camera, go to the bottom, focus is focus, high quality, why not? Go to f-stop and here put some ridiculously low value because the monkey is now 2 meters by 2 meters, so it's really huge. So here doesn't have to be something correct for actual camera, something like 0.3 or 0.4. Back to the camera, let's see if it has actually some effect. It should be blurred on the edges only, and now you can just hit the render, why not? Okay, the render is done, so let's just apply the same old trick as always in the compositor. So back to the node editor, composition, use nodes, and just distort it a little bit with where it is distort, lens distortion, fit, dispersion 0.035 for example. Well, it's maybe too much. 0.016, it's better. This will took our alpha away, so we need the alpha channel to make the same distortion and get the colors away. So use saturation value and saturation to 0 and put it to alpha. And it's pretty much all. Just put some nice background under it, like in this image. The backgrounds are usually just going to Google and put something like blurred background. It's not exactly rocket science. Just make sure you have the licensing so you can use it again in the maybe in the paid work, and you want definitely the big resolution or large. I am not sure how the translation is now. I believe I picked this one for the background. The alpha should be already cut it out, and you have your image. So this is actually all for now. If you have some requests for another tutorials from other software, it doesn't have to be only Cinema 4D. It could be Maya, Houdini, something else. I will try to recreate it in Blender. And till the next time, bye.